Hey everyone, Darwin Sonoy here from GitLab Alliances. I work primarily with our AWS Alliance, and I have a 6-minute explanation video on how GitLab does Get Ops for you. I wanted to let you know that this is part of a really exciting workshop we're currently running with AWS at some of their offices around the world. You can see the ones that are currently scheduled, and for more information of a syllabus as well as to register, you can go to the URL on the screen. As time goes on, we'll add more workshops to the docket, and you can continue to visit this URL to keep up to date with what's going on. I hope you enjoy this explanation. All right, let's talk about how GitLab does GitOps. Before we get right into the details of how GitLab does it, we need to talk about the fact that there's been two major definitions of what GitOps is that have evolved in the industry over time. So we'll talk about the first one. Is basically the idea that it's a Kubernetes thing. So we have a new concept of pull CD where we install an agent inside of Kubernetes, and that pulls the software updates onto the cluster. We use Git merge controls in order to control any deployment type situations that we want to have more control over, whether it's security scanning of manifests or controlling the approval of deployments. And then we have a new capability, which is pretty interesting, which is continuous drift management. Now, this has really been the forte of things like Chef and Puppet in the past, completely separate products. But now with the GitOps approach, we integrate that right into the standard deployment agent. And then finally, the main focus is Kubernetes Targets. So we presume that this is all running on Kubernetes. So in this case, we start out with our application code in a repository. We use continuous integration to then build that into a container. Once we have got that container set up, then we are able to reference it in a manifest, which is also stored in Git. Now, this manifest is going to be a completely rendered manifest, which means that there aren't any variables in it. It is ready to read, plain and simple, exactly everything that's going to happen. It also means that we can scan it and check it out and make sure that it is in good shape. Then we have an agent that we install into the cluster, and this agent does two things. First of all, it pulls onto the cluster. Now, we can also insert approvals in this pull operation if we wish to for major deployments. Then the second mode that it has is that continuous drift management. And of course, in this mode, it just directly pulls the manifest and reinforces it. This way, if there's any tinkering that goes on in production or other environments, it is brought back into compliance with the standard configuration relatively quickly. So that's an example of what GitOps defined as a kind of a Kubernetes thing. Another definition of it is that our source code management system would be the same system that builds our software will now deploy our software. It easily allows for push CD. It also uses Git merge controls in order to control deployment approvals. And then finally, we don't really have any restrictions in terms of what targets that we allow for this situation. So we start again with our code repository, and that is built by CI. And then within CI, we have some sort of approval process for doing push deployments. The push deployments can then go to basically any kind of infrastructure you want using a variety of techniques within that push CD mechanism. So these are the two major definitions that have evolved over time. Now, how does GitLab approach this? What does GitLab do in order to service one or the other of these models? Well, in reality, we service both models. So the concept is just to go ahead and do it all. Part of the reason is we've had the right-hand side for a long time. So we've been putting Git merge controls in front of deployments for a very long time already. So let's talk a little bit about how GitLab is doing that now that we have the GitLab agent and how that kind of changes the mix here a bit. First of all, we do indeed need the GitLab runner for CI. Notice that no matter what you use for GitOps deployment, you still need CI. GitOps really solves the CD portion of the problem. The really nice thing about having added the agent is now in the single platform, you are able to manage both your CI as well as your pull CD. So we use a runner for CI, and then we have the new GitLab agent, which runs inside the cluster. That GitLab agent is able to accomplish both pull CD as well as drift management. So it's able to give us all those services and provide us a very comparable solution for the Kubernetes definition. Now, over here on the deploy from Git definition, we of course have GitLab CI again for building our application. And then we have GitLab runner for CD push. Now, we've been using GitLab Runner for a very long time for CD push. In the past, the certificate connection method has required that your Kubernetes cluster have its API control plane available to the runner, so the runner could reach out and reach into the cluster through that. Not a big deal if you're all on private networking, but if you're trying to use GitLab.com, well, then you'd have to have that API control endpoint on the internet so that GitLab runners, if you're using SaaS runners, could service it. You could also do self-managed runners and solve this problem by putting your runners in with your Kubernetes cluster. But in any case, customers spoke and wanted this part also to be more secure. So when we add the GitLab agent, we change how this works. Your Kubernetes API control endpoint no longer needs to be available to the runner. Once you install the GitLab agent, it is able to establish a secure connection. Now, technically, it doesn't go back directly to the runner. It goes back to the GitLab instance, and then all runners can find that connection and utilize it in order to go to certain clusters. And so there's a little bit of intermediary here that we're not depicting, but suffice it to say that the agent reaches out and establishes that secure connection with GitLab, and then the runner is able to use that secure connection in order to push Kubernetes commands onto the cluster. So one of the really cool things you should be able to discern from this is, even though we are retiring the certificate connection, you can use the GitLab agent for CD push. So if you're not really at a point where you're worrying about GitOps as far as a pull technology, it doesn't matter to you or it doesn't work very well for your scenario, you can keep using GitLab as you use it today, but we're going to be a lot more secure as far as that goes. So hopefully this helps you understand what GitLab is doing in the area of servicing GitOps with the single DevOps platform.